Hello everyone. So let's discuss problem 1.13 of electric field and charge chapter. So as per the question, the spheres AB are identical in sizes. So this is our sphere A, this is sphere A, this is sphere B. Now we are supposed to refer to the previous question, and previous question says that the charge on both of them is 6.5 into 10 raised to minus 7 coulomb. 6.5 into 10 raised to minus 7 coulomb. Now there is another identical sphere C which does not have any charge. So I'm going to put 0 coulomb charge under the C sphere. Now C is brought in contact with A. So this is A, this is C. Now I just want to make a point, guys, that those of you who does not know this concept needs to understand that what is going to happen if the spheres are identical and if the spheres are not identical. So first of all, this is A and suppose this is C. So this is our C sphere. Now this has charge. Suppose this has charge Q and this does not have any charge. Now if they are made to come in contact directly or say through a metallic wire, if they are being joined through a metallic wire, that's totally fine. What is going to happen? The charge transfer is going to happen from high potential to low potential. Now since A is already having positive charge, so it will have some positive potential, and C does not have any charge, so C has 0 potential. So the charge transfer will happen from A to C, a body of high potential, to a body of low potential, such that the potentials become equal. Now this you will learn in the next chapter, that if you have a sphere having radius r and the charge on its surface is q, then the electric potential is given by k q by r. So here, since both the spheres are identical, their radius are also the same. So the potentials will only become equal if there are equal amount of charge after coming in contact. So what is going to happen? Afterwards, after touching, if both of them have equal amount of charges, since the radii are equal, so now the new potential on A and B, this is A and C, sorry, VA and VC will be equal, that is K Q by 2 by R. So charge distribution will happen in such a way such that the potentials become equal. And in order to make the potentials equal amount of charge will be distributed in both the spheres. So if one is having suppose Q charge, then Q by 2 will be appearing on the surface of both the spheres. If the spheres are not identical, then the charge distribution will not be equal, the potentials will be equal. So in any situation you must understand that the potential must be equal, not the charge. But here it is an exception. Because the spheres are identical, we will have equal amount of charge in both of them. Right, guys? Okay. So now if I touch A and C, A has this much amount of charge, C has this much amount of charge. So A is going to lose half of its charge to C, such that the potential on both of them become equal. So now both of them, they will acquire 3.25 into 10 raised to minus 7 coulomb charge. Whereas B is still aside and no process is being done till now on B. So this is 10 raised to minus 7 coulomb. Okay, now let's look at the second line. This was the first line which we had already solved. Now then brought in contact with the second one. So now C first of all was brought in contact with A. Now C will be brought in contact with B. So this is A, this is C, this is B. Now B was already having charge. This is say C, this is B. So this was already having 6.25 into 10 raised to minus 7 coulomb charge. And now this has I'm sorry, this is not 6.25. I made a very small error over here. This is 6.5. And this is again 6.5 over here. So this is 6.5. Here also it is 6.5. And C has 3.25 into 10 raised to minus 7 coulomb. So now the charge is going to go from B to C such that the potentials become equal, and after coming in contact, equal amount of charges will be there. So it will be 6.25 plus 6.5 plus 3.25 into 10 raised to minus 7 coulomb divided by 2, which is 4.875 into 10 raised to minus 7 coulomb. Now this will be the charge on B and C. So let me put it over here. This is 4.875 into 10 raised to minus 7 coulomb. Now this has charge 3.25 into 10 raised to minus 7 coulomb. So now what is the force of repulsion between A and B? Right? So now let's find the force of repulsion between A and B. So force of repulsion will be equal to K, charge on A, charge on B, and the distance between A and B does not change. So earlier the distance between A and B was 50 centimeter, which is going to be the same over here. So it will be r square. So if I substitute the value 9 into 10 raised to 9 into QA is 3.25 into 10 raised to minus 7 multiplied by 4.875 into 10 raised to minus 7 divided by 0.5 the whole square. Guys, this diagram was just to show you the schematic representation, but we are not changing the distance between A and C. The distance between A and C was previously 50 centimeters. After the entire process is getting over, this distance is still 50 centimeters between A and B. So this, if you solve it, you will get your answer as 5.7 into 10 raised to minus 3 Newton, which is the answer to our problem.